After we know how can we measure the distance, or you can think that it is a similarity between the two examples, what we have to do next, um, we can cluster them. And the idea is, I'll talk about the first one that is very, very important one, and is a very well known algorithm that we can use to cluster the data. I'll demonstrate using just only the two-dimensional one, two-dimensional space one. So you can easily see the image, the how can we use this algorithm. This is k-means. Uh, the idea is quite simple. We will use k cluster. K means k cluster. So we start with the space of an example. You can imagine that if we have x and y, or you can think that if we use just only the sepal length, for example, and sepal width. Okay, and we have the data like this. Okay, at first, we can start with an example like if we use k to be 3, for example. If we use k to be 3, we start with randomly generate the centroid. The centroid is the center of the cluster. So we can randomly generate the centroid. For example, if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 7, 8. For example, if we have 8, if we have the data like this, we'll generate randomly generate the centroid. For example, we can generate the centroid like this. Here, 3 of them, because k is 3. So we will have 3 clusters. And the idea is quite simple now. We will have 3 clusters. And we start with each example. We will iterate through all examples and measure the distance. A moment. I will change the color of the centroid. Make it different. Okay. So we will measure, for example, if we start with this example, we will measure the distance between this example, oh sorry, we will measure the distance between these examples and all centroid. And we find the closest one. So you can see that this one is the closest centroid is the red one, right? So we will cluster them using red, group them to the red one. Okay. So how about the other? How about the other? Uh, for example, if we use this, if we focus on this example, so we will have, oh, sorry. Okay, 1, 2, and oh, sorry. Okay, so we have to choose the closest one. So if we measure and find that, okay, the red one is the closest. So this example will be clustered to the red one. And how about this one? So you have to measure again. You have to do it. We have to iterate through our example with these same steps. So we start with this. So you can see that the purple one, right? That is the closest. So this one will be classified, will be clustered to the closest, the purple one. Okay. Okay. So and we can do it, and we can repeatedly do it, and uh, the idea that you can use in our algorithm, we will use the same one, the same idea, but in our demonstration, we can use something like this. We can divide it into a half and draw a line. So the example in on this side, if we want to cluster between these two, uh, so the one on this side will be red, and the one on this side will be green, light blue. Okay. Okay. So I hope that you can imagine. Oh, and same, you can do it with this line. Divide it in a half, and then draw this one. Okay, so uh, on this side will be purple, light blue, light green. Okay, so I can easily cluster them. Okay, and that is the red cluster. Oh, okay, and this is the purple one. Okay, so this is three groups of the example. Okay, so then when you clustered them already, oh, actually, okay, so now in the second in the second round, I think this example is not exist. It doesn't exist in the first iteration, but I think it's on the line something. Okay, don't worry about that. So now we have three groups, right? And and once we have these three clusters, we can find the new centroid. We can find the new centroid using the average of x and y of each example. So uh, this centroid, the purple one, will move to. So you have to find the average of all x here. You have to find the average of all x and all y. So what we got will be something like the new centroid that is moved to the center of each cluster. Okay, so this one will move to around here, and this one the red one will move to, like, this is average of x and this is average of y, so it should be around here. In our programming we have to calculate, but this one is like just the demonstration. So now we can do it the next round. We can find the next round. So I will use this line to guide us. Okay, I will use this line to guide us. Okay, so uh, so these must be, oh sorry, must be purple. Okay, and this one, the second cluster. This is the red one. Okay, so the purple are like the almost same, right? And we will move this centroid to the next here, and the purple are almost the same. And we will move the red one, calculate the new centroid of the red one. So it can be this centroid. So now this is the like almost the same as the previous one, but not still same. It still has uh, has something that some examples change. Okay, so so maybe if it's on the line, you can randomly choose the cluster. So we have the cluster like this. Okay, so uh, these are the new cluster, right? And again, we have to find the average. That is almost the same, right? This one will move here, and the red one also Okay, so we have to repeat it until there's no change in the groups. So we will repeat it until there's no change in the cluster, and we will report the centroid of the cluster to be the representative of each cluster. And you can think that, okay, we will represent each group using the centroid instead of representing all examples. Okay, so when we finish this, we can use the library of Python to demonstrate how k-means work. But we will have some like some choice to be made before you have to decide how many clusters or what is the values of k do we need in each clustering. So many people use the uh, elbow method that I'll talk about the elbow method in the next video clip.